I'm going to stay over this way because that's what I'm told to do. I want to thank everybody for coming out. My name is Mike, the VP of Engineering here at CloudSpace. I think it kind of, does everybody know what we do? Do web design, mobile design, right? But want to thank everybody for coming out. This is really cool. The community and everything that we're doing with the meetups is really starting to grow. One of the things that I would encourage all of you to do, and at least some of you, is to give a presentation, right? When you want to learn something, the best way to learn it is to give a presentation, right? So I'm going to encourage all of you guys to get deeper involved in the community and come on up here. It's really not that scary. It's a team of peers, right? We're all here to learn. We're all here to learn together. So I do want to encourage you guys to do that. If you guys have any questions, there's pizza on the back, there's drinks in the fridge, there's Red Bull, and I'll let her tell you everything else. So, but if you have any questions, feel free to stop one of us. Always like to talk, and then after this is over, we'll go next door and we'll do some more chatting. So thank you very much. Larry.
All right. So thanks for putting up with my dog being here. Other than that, so this is the first JavaScript of the year. Woohoo! This was also one of our first ones we ever launched, and it's also our biggest, which is great. But we also have 3 other meetups that I would love to see some of you guys kind of get into more. That way you can learn more. Some stuff may be over your head, but at the same time then you can go home and learn those things that you possibly heard about in the talks. We have JavaScript, I'm thinking last week. We have Android coming up next week. So if you go up on any of the meetups, it's University Android, that is next week. We'll have the speakers up soon. Thank goodness. We're good now. We have Ruby also coming up. After that, we have not done a Ruby since October, just because of the holidays, because it happens to be the 4th week of the month. So we're pretty excited about Ruby. I know it's a new language, but still, you should come out. So that's also coming up. A couple things different. You guys should have already seen all of this fun gear, but we have new t-shirts. And some of our guys are actually wearing them. Nick, I'm sorry for embarrassing you, but you're wearing one of our t-shirts. I'm giving one of those away. So that's what the raffle ticket's for, and also for the books. I still would love it if you guys would do the hashtag. You could do UniversityJS if you want to, that way it's shorter. Because I'm still going to give away the gift bags. So I'm going to do that with the Twitter. Do the Twitter. Sorry, it's becoming my catchphrase. So other than that, thank you for putting up with the new sign-in sheet. If you guys do come to another meetup and you've already filled that out, all I need is your first and last name for now. Until we do put it on our website and everything else. We've been a little busy on project side before we can put it on our website, which is still good news for us. Just, you guys have to put up with Google Forms. Let's see, what else? I'm blanking out today. Bear with me. Let's see. I think that's really it. So other than that, Vikram, would you like to come up and speak? Who's also saving my butt next week?
Let's see now, how does this work out?
All right, just put it in a pocket. Any pocket, doesn't have to be that pocket. Any pocket.
So
And then just attach that to your shirt.
Let's see.
It's just a live stream can pick you up.
Oh yeah. Let's see, does this work?
Yep, you're good to go.
I have to worry about this like working or something, is that?
It's on.
Okay.
You're all good.
It's on. They're hearing you right now.
Perfect. Hi, good evening. So how many people here actively work on JavaScript-based development frameworks? By a show of hands. It's a lot of people. Good. That's really good. So recently the trend in JavaScript has been that everything that can be written in JavaScript is being written in JavaScript. I mean, it's crazy the amount of things you can do now. Even 2 years ago, you couldn't do half of them. Like one of the ex-Google engineers, I'm blanking out on his name now, but he made a library where you could do like in Google Docs, you can see someone live type. There's actually a JavaScript library to implement that in like 4 or 5 lines, which is ridiculous because this was never possible without at least like 15,000 lines of code, maybe more. probably more. So today I'm going to talk about one of the things called mean stack. So what is this stack word? That I actually want to talk about first before I go on anymore. Recently, so I hope a lot of you are getting into the habits, and if not, you definitely should, of reading development blogs. One of the blogs I read a lot is Fred Wilson's, and he talked about, Fred Wilson and Chris Dixon, they talked about emergence of these full stack startups. The idea is that startups no longer are building just a product, but they're building the product and services to support around it. The idea of a stack is like a stacked burger. It's not just the patty, other stuff on it, like lettuce and so on. Stack basically adds more flavor. Well, one way to say it is adds more flavor. More than anything else, a stack gives you a bigger kind of overview of what is possible with the language. Mean stands for Mongo, Express, Angular, and Node. 4 parts of the framework that make this thing just crazy powerful. This was started as an open source project by a company, Lenovo. I'm blanking on the name too. Anyway, the company's not important. The stack is important. It's open source. In all fairness, they should get the due credit. I just forgot what they are. Anyway, here are the 4 components I talked about. Mongo, very quickly, I'll mention all of them. Mongo is a database type thing. I'll get more into it. Mongo is also planning on IPO. IPO is when a startup gains enough people, enough business, and they're ready to go and become a public company. It's a huge transition. They raise a lot. Box, which is a previous Dropbox competitor, is planning on raising about $163 million in one IPO. So these are the kind of numbers we're talking about. It's crazy. So Mongo is exploding. Express is actually the web development framework that works on top of, particularly Node. Angular, everyone's probably favorite language, incredibly popular. Basically, Google's power in your own hands. Google created Angular, or a lot of developers inside did. Node is the JavaScript engine. Not JavaScript engine. Well, it is kind of, but it's the engine that came out of Chrome. Node.js powers Chrome, kind of. The V8 engine, to be technical, the V8 engine inside Node powers that. Details aside, it's pretty cool. The reason this stack is so powerful is because Express and Node can do a lot of middleware work. Node can do almost all work of the back end. Express can build kind of pretty websites. Angular gives you MVC and front end, and Mongo gives you the database. So do you kind of get to see you can do everything? I mean, front end, back end, all you need to know is JavaScript. Every one of these frameworks uses it. Basically, you're in kind of a lot of people, including Jeff Atwood, call it JavaScript heaven because basically everything's turning into kind of one language, converging and then expanding out. Converging as in you need to know less and less. Expanding out as in the libraries are getting crazy. I'm not going to be able to talk about Angular or Node today. 2 reasons. One is I don't have that much time. More importantly, Angular and Node both are very and already very well used. I'm sure most people here have either heard or used one of those 2. I do want to focus a lot on Mongo and Express. The benefit of focusing them, you can't really talk about Express without talking about Node or Angular. So we'll cover them anyway. So what is mean? Mean, this is the kind of the definition type thing that the mean website, mean.io, gives out. Just read a little bit. It's blah, 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 full stack framework, blah, 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 accelerates web development. Those are the 2 main things in the whole definition. Again, I mentioned a little bit earlier, full stack just kind of means it's a full meal. You're not just getting an appetizer. You get actually eating your full afterwards. Accelerates web development is probably the more interesting part to you guys. I started to make an simple app where you can just interact with some users. It's called CRUD, create, replace, so on and so forth. Users and then the D is the delete. Basically, it's user interactability in a basic app. And I could do it in about 2 hours. And I haven't been using Mean for that long. My point is, Mean gives you an incredible amount of power. And I mean, it makes sense too, right? So Node.js is very, very powerful. Node.js can do most backend work. Then you have Angular, which also gives you a lot of flexibility, the front-end development. It's like, if those of you who've used Linux or any sort of package management system, it's like sudo apt-get install, right? So you install packages that way. Mean, you can install a lot of packages. similar way. Just kind of giving you guys one, like a big, what's a subset of what's available in Mean. Just a few ones I want to highlight. Upload and Socket. Those two are like generally the ones you probably would be using a lot. Socket lets you do WebSocket development work, and Upload just kind of takes care of uploading like files onto the server. A similar framework like Meteor. I don't know if people are familiar with it, but basically the idea is that you give a lot of frameworks or a lot of commonly done tasks in a very easy to understand and implement way. You shouldn't have to implement the login button type thing every single time you make an application. If you're going to have it, provide that as a framework. All you do is import and install, which Mean allows you to do, and you change some parameters that you need to change. Who remembers playing with LAMP? This is a very, very popular thing you learn when you start into sort of web programming. Mean and LAMP are actually very similar. Some of the ideas behind Mean, the understanding and the philosophy behind why Mean was made, a lot of them come from LAMP. LAMP was originally, the idea behind LAMP was that you would take what is available out there, like some of the common ones, Apache to run your stuff, PHP, still probably one of the huge languages used, and then MySQL. MySQL is the kind of the more popular mainstream type development backend for SQL. Mongo is the other one, the more recent emerging. There are a lot of differences in the two. I'm not going to get into the two of them, but for a lot of them, Mongo ends up being the better choice, which is why evident by how popular Mongo became. So I mentioned about this earlier. You can do everything you could in Mean just by knowing JavaScript. This is crazy because, well, for several reasons. One, if you go back to the idea of LAMP, what was LAMP allowing you to do? You basically used like 2 or 3 clicks, and just in that much, you could set up a web server, have it running. You transfer some files on it, and you got this thing working. Then you can play with PHP, and you have that running too. And you could create a development server. I mean, obviously that was more complicated, but you could use LAMP to kind of see how your things would turn out. Mean gives you the same kind of power. The design principles in the Mean kind of go back to a lot of other things like continuous deployment, continuous integration type things. These are more advanced development techniques that most people or most developers would use in heavy projects. Like big projects generally get developed, broken into smaller pieces in these techniques. And Mean kind of allows a very good framework to get started in them. One of the reasons I really like the Mean framework is not just because Mean integrates these 4 components very nicely, but more so because it forces you, like really you have to use good principles and techniques. So one way or another, you like it or hate it, you end up using a lot of the good practices, that we consider good practices. So an example, so basic C code, like you declare integers like int a, b, and c. That's a recipe for disaster in big projects. You need to name your variables properly. It's a very basic thing. We all slack off on it here and there. But in a bigger framework like Mean, you would generally want to, the way it's structured, so Node actually makes you want to name them properly. Because if you don't, you're screwed. You wrote like 2 hours worth of code. If you didn't define variables and so on properly, you are absolutely screwed later on. You're not going to sit there for 4 hours debugging when you could just make the whole thing again. Let's talk some of the advantages of why Mean is becoming popular and why anyone if you might be interested in it. Again, the biggest advantage I keep repeating, one tool. That's it. You don't need to know more languages. JavaScript is it. MVC. MVC is sort of MVC kind of gives you a uniform frame, the uniform idea to work over. So it's the message view controller pattern. You have basically the user interacting with the server interacting back with you. In some sense, the MVC kind of gives you a standardized model of working with the user, and it's predictable, how the user would work with you and how you would actually go work, interact or provide results back to the user. MVC is very, very common in most front-end languages, and here MVC is obviously available because Angular is in. Angular gives you directives and so on, other really cool things that are all available under a pretty extended like MVC pattern. transferring data. So that's another big deal. So when you're making a lot of backend applications, and there are some recent startups that actually just got built around the idea of transferring data. So Keen.io is a recent startup that was around. I think it started 2009, 2010. But basically Keen doesn't do anything crazy. It just allows you to record events. The idea is they put the events in JSON format. JSON format is a JavaScript object notation, very easy to read and understandable format that allows you to systematically separate events. So the idea there is you upload a whole bunch of events, right? And you separate them out. But once you have them in this JSON format, a lot of other applications can use it. So another thing that Mean does, and by the way, slightly off topic, but Bitcoin blockchain does the same idea. They're called enabling applications because they enable the data to be messed around with. So they make the data available to be tampered with. JSON does the same thing in the Mean can actually and has been used in some pretty advanced applications where the data can be interchanged. So once you can store data in JSON, Node can use it, maybe Angular can use it for something, and then you can switch between them. That's in higher. It's called message passing, but we're not going to get much into that. Message passing is far more complicated, but JSON actually accomplishes a very similar idea. The idea is that you frictionlessly transfer data from one component to another, to another, to another, while maintaining the integrity and the data itself. So integrity just means if the block was this 1, 2, and 3, when you transfer them, they don't get transferred as 3, 2, and 1 or whatever. They get transferred exactly that, and you have a good confirmation that they are. Also, for those of you who do work in Node or have developed in Node, Node.js is incredibly huge in terms of its libraries. What they support, again, the idea of providing building blocks to do common repetitive tasks. Again, including Node in the Mean stack makes obvious sense now that I mentioned that. Last one is actually probably one of the most fun. If you really get interested in this and you over the next month or two understand the Mean framework pretty well, here's the cool thing. You can tear it apart and make your own framework. You don't have to use Express. You can use React. You don't have to use React. There's Backbone. There's a ton of other things that are JavaScript kind of alternatives. They wouldn't exactly fit as well as Mean does, obviously because of the top 4. But if you can match the top 4 points here, you could actually make your own framework, which would be pretty sick. I mean, imagine that. Like you kind of made your own toy framework and try to play with it. Another thing is that one of the best ways to learn a higher level programming framework is to tear it apart and see what works and what doesn't. You're going to get stuck, you're going to hate it, but in the end, you're going to learn a lot. I remember when I learned learning Linux, Ubuntu, I was installing Tomcat. Took like 3 days, still failed. But I learned so much about system links, installing apt-get package managers. In retrospect, I was probably 14, 15 when I was doing that. Not a good time. Anyway, I learned a lot. And so actually the framework is pretty accessible. There's a lot of help on it. Stack Exchange, you can see Angular is like a huge tag. I mean, the way to get help on Mean, that's actually another benefits I probably forgot to add here. The benefits of having Mean is that you can also go to help for the components. So if an application that you created in Mean is not working properly, just go and if the problem's in Express, you actually just go to an Express kind of like form or some sort and ask help there. You don't have to ask for a Mean particularly. You just know your components work. As long as they work, the sum of the whole application should probably work. So let's talk about Express. What is Express? So Node.js is a very powerful language, but Node provides, it misses out on some features. It provides a lot, but it does miss out on some. Node actually gives you one of the really big things that Node does is called asynchronous loading, where objects don't have to load one after another. So if you have a website that's loading like 20 things, oftentimes the website will be coded to load 1, then load 2, then 3, then 4, then 5 in that sequence. Obviously, that makes sense why that would be so slow. Even earlier, in very early days of Web 2.0, when Ajax kind of came about, it was a disaster. It didn't work as well as planned. And the sequence of the events was pretty much like that. Like 1, 2, 3, 4. Even with Ajax, they would load like that. Node allows you to do asynchronous programming. So 1 can load, 2 can load, 3 can load, and they don't lock. Locking just means they don't obstruct each other up. So when Node does that, building on top of Node to build front-end applications, one of the fastest middleware to get those down is Express. If you start learning tutorials or anything on Node, the first package they'll tell you to install is Express, and it's because Node by itself can't do a lot of crazy web front-end development. Express, on the other hand, probably can do a lot. And then if you really go above that, the next step would probably be Angular. And now you're adding, like, just open a new Pandora box. You add a lot more features, a lot more interactability. Probably make the code easier to read too. If you've read Angular code, it actually looks very much like HTML, just a few extra garbage added here and there. But it works, and that's great. So next thing I'm going to talk about is the idea of Mongo. Too intimidated by this picture. I'll explain what that is. But basically, Mongo is another kind of database type program. That's not too accurate to say it's a database program, but it manages a lot of database work. And like I said, they're huge. And this picture kind of actually gives you an example of what Mongo would look like being integrated. So to try to follow along here, up at the top, the routers. Routing is something where, so if you're going down Colonial and you want to go to this shady shop, I don't know why you want to go there, but your GPS would tell you to go down and make this turn. The router tells the app, as the user explores the app, what do you present him with? Your GPS presents you with a new turn, a new road or something when you're on the road. A router presents you or presents the user with the alternative options. Here the idea is the router can actually interact with the database itself. So you actually get to keep, like if you're logged in, you get to stay logged in as you're exploring other parts of the application. The router can do a lot more than that, but that's very basic idea. And also user privileges. So you don't want a user exploring every part of the site with the same level of privileges. If you go to change your account, you have probably 100% privileges, right? So you should be able to change, it makes sense. You should be able to change your name, your IDs, your password, all that kind of stuff. You probably don't want that when they're exploring another part of the app that's sensitive to other users. So that's kind of what the side on it's showing. 3 config servers just kind of means that there's multiple servers or multiple parts of the app holding different configurations, which then allow the router to interact with the data set. That's what the shard is. I'm not going to get too much into what the shard is, but this picture is only here more or less to give you an overview of how Mongo interacts. Mongo kind of sits in the middle to help the users interact with the application itself and the stored data. It's more or less stateless, but let's not get too much into it. And now I want to go back to Atwoods Law that I talked earlier. I see from a few smiles that you guys probably know it's Jeff Atwood. He writes at Coding Horror, probably one of the best blogs of all time. He writes a lot of programming and stuff, but this is actually 2007. One of the things with visionaries is they can see changes happening a lot earlier. 2007 was not when Java was exploding the way it is now, even the way it was in 2012. But Jeff Atwood predicted that, and it's true. More or less everything that's crazy that could be written is coming out. So like if you are familiar with D3, it's a charting library, so it allows you to make very pretty graphics, nice and looking everything. And you can do that all in JavaScript. So that's another thing you can add on top of mean. Like you can keep finding external libraries and add them up to, for instance, you can add them to Express. Basically, you're not adding anything to your application. Your application still uses the mean stack, which is a very standardized framework. All you're doing is adding on top of Express, which is completely a separate feature. This kind of modularity allows you, if you do like really like heavy work, sometime in your career, it allows you to change things around very, very fast. So if I have an application that is screwing up and I don't know what the error is, if it's modular, it's very easy to trace your steps to see where it is. And the modularity kind of really gives you the idea. So overall, a few things that I wanted to get across in the talk, I just want to review. Obviously, it's impossible to review the whole framework, right? In 30 minutes, I can't give you everything in mean. The idea was to get you guys somewhat familiar with the design, the philosophies behind mean, and the idea, what can mean accomplish? So any of you who are familiar with JavaScript and want to take it up the next, what's one thing you can explore? You can do crazy crap with mean and nothing would go wrong. You're building a web app. If anything goes wrong, just shift delete. Things delete to start over again. So I hope that this gave you guys some introduction to what mean is, what it does, and how it functions. I hope some people try it out. Thank you. Oh yeah, any questions? Forgot to take questions.
of stuff that I want to process, do I have to do it through Node? Is there a built-in functionality, or would I have to write a custom package and say, oh, you
Depends on what kind of data it is, structured, unstructured, so on. But Node will most likely process it. Node is very, very rich on that. YouTube, I remember looking up this guy's video who just showed how fast Node can process data.
Yeah.
He had like a few gigabytes of data. All he did was input and output. That's it, for the hell of it. But like you can do a lot with it.
Okay. Fair enough.
Sir?
Do you have any notable examples, like maybe on GitHub, of people that have used the mean stack to build an application that we can pick apart? And
Mean.io, click on examples. There's at least 100. I don't know how many, but there's a lot. They have their own, like Mean itself is on GitHub, so you can find what they are made of, and they have examples to showcase, and then they have a showcase to showcase other stuff. Sir?
how is using Mongo in comparison to something like Postgres or MySQL?
You know, the real advantage of Mongo comes in when you incorporate it in these stacks, because Mongo is very easily interactable. From what I've worked on so far, Mongo interacts very nicely with Node and the other packages. That's one very like kind of practical, foreseeable implementation. Other than that, for the most part, they're the same. If I'm building a task list, it doesn't matter what I use, right? Like, and if I'm building a simple login application, probably still doesn't matter. Though I know a few friends who work on like pretty like data-intensive applications that like are custom for enterprise software. They all use Postgres. And so, sir.
Thanks, man. On that level. So Mongo is a lot more free than the SQL. You don't have to define a schema. If you want to throw something in Mongo, it just accepts everything. So it's pretty cool, but it's not relational. So you can't take something from another database and then import it dynamically into your Mongo automatically in real time. But calling your collections and everything, which are essentially tables, it's basically JavaScript notation. You just use dots. So you do your MongoDB database dot collection dot whatever.
Oh, yeah, they're all additive.
Yeah.
Okay. So is there still sort of like a where equivalent where I can look up by a property?
Yes.
Okay.
Basically.
Yeah. The same kind of theme of asynchronous loading goes on more than mode. It actually holds on a lot of the stack. Thank you for bringing that point up, by the way. That was an excellent point.
What's the website?
Mean.io. Yep. Sir.
How would this be different from using all those libraries independently and just sticking them together to build them out?
More difficult to get it ready. So you have to individually actually install all of them. You have to prepare all. Mean is just npm install mean, I think. Online and you install everything. Yeah, easy to set up. More importantly, I think the big difference between all of these, if you do it individually, you don't get the same kind of interactability between all the other components. That's kind of the part of the company behind that created Mean Stack. The idea was to be able to easily transfer between all of the frameworks that you want to use. And doing that individually, sure, it's possible. Hours figuring that out, but you know, that time could be used for development. Is that it? Awesome. Thank you, guys. Yeah, 1 second.
All right, something I did forget to mention. We are on YouTube now. This is Livestream.
Oh God, really?
Yeah.
Well, okay.
By the way, you're on YouTube. So it's university. it's University Tech Meetups. It's an actual YouTube channel. We have the last 4 meetups as well. So you can actually go through and watch the whole entire meetup, which is great. It's kind of embarrassing for me because I'm a horrible speaker, and this is really entertaining. You actually catch me not in the frame, and in the frame, it's wonderful. And another thing, too, the raffle tickets I gave you guys will be for the books and a T-shirt. So that will be after David is done talking. You can get set up while I'm, get set up while I'm talking. And what else? Oh, one other thing. When you guys were filling out the Google form, I did have a little mention in there if you guys had like a demo or a website that you had been working on. What we're going to start allowing to have in here, you guys can totally let me know. These are all the inputs. It's right here. And that's why I wanted to kind of know if you guys were working on something. We're starting to want to give everybody about 5 minutes. We'll maybe do 1 or 2 per meetup. About 5 minutes to kind of quickly go over your app, but what is your problem? Like, what are you having difficulties with? And then that allows a good about 10 minutes of like an open forum for everybody to come in. God, you're killing me, David. So that way everybody can kind of ask questions and kind of help guide you along on an app that you're working on. So that's what that question was for. So I'll be contacting people on that. You're killing me. All right, darling. Okay, guys, this is David. Eat pizza, please. Yeah. Take it. Go. There's more. Eat it.
Put this here. Just put this on my butt.
Well, far better than the Ninja Girl I used.
All right, can everyone hear me? Or are y'all getting? I don't know what's going on. All right. Well, if you want to learn to make web applications, my talk is not going to be nearly as useful as his because we're learning about animations and goats. We're talking today about the Web Animations API, which all of you get hipster points for because it's probably the coolest API that you have most likely never heard of before. Because the Web Animations API came out only about 8 months ago, and it's pretty revolutionary in that there's almost nothing new about it. I'll explain what I mean about that. So, you guys remember Flash? Back in the days of Flash? Flash provided a standard for interactive web animations so that developers had a platform in which to all create animations in a variety of browsers. They could do things such as music, keyframes, tweening, all sorts of things. It was mainly good for games and videos, and it still is right now. Try to implement a game in HTML5, you're going to have a lot of headaches, and also restaurant websites love Flash for a reason. That back in the good old days, Flash was sort of a cornerstone of the web where animations were pretty ubiquitous in the web. Granted, they were flashy, they were tawdry, and they were a little bit annoying at times. But in 2010, Steve Jobs announced that iOS will not have support for Flash. So the web developers who worked on Flash just decided to, I don't know, go in exile or something. But the point is, we don't really see much of Flash anymore unless you're doing video streaming or games. And that is soon going to be replaced too. The technology is still being built for that. But yeah, Flash is basically becoming extinct. So what do we have instead? We have things such as CSS animations, CSS transitions, but for a while, everything was just sort of flat. When Flash animations disappeared, suddenly we had more static websites, and now we're moving more towards an emphasis of animated websites. Many people think that animations are just for decoration, like it's just an afterthought, but that's simply not true. If you are a mobile developer, you know that animations are very important in what you do. Lots of mobile apps incorporate animations, and it's above and beyond what we could do in the web right now. Sad to say, we are falling behind in web animations compared to animations on your phone. And you guys might recognize this. This is from Google Material Design. This is an example of what they call meaningful transitions. And even Google recognizes the importance in the web where animations are used for interface effects, where every single action has a meaningful transition, a meaning to it where, for example, if you press the button, it's clear that the relationship of you pressing the button is to the play timeline. And it's also useful for storytelling and visualization. Take infographics, for example, or any sort of complex graphics used to portray information or a story. You can't just simply show that in a flat way. You need to animate it and show how all the parts relate to each other. Needless to say, animation is very important in the web. And animation also looks pretty cool, you guys have to admit. It's not just enough to show something that looks pretty, but you could only stare at it for so long wondering what it's going to do. You want every single one of your actions to mean something. What we have right now, like I mentioned, is CSS animations and transitions. The good thing about these is that they're hardware accelerated, which means once you put the animation in CSS, the browser takes care of the heavy lifting of calculating the animation and making sure that it runs smoothly and efficiently. However, CSS animations are declarative. They're from point A to point B, which means you have a single animation. You can't really have a dynamic animation where if I click this or if I do that, then the animation changes. Otherwise, your CSS file is going to get pretty huge. Also, there's no manual place state manipulation. You could sort of manipulate place state with animation place state, but it's pretty difficult and it's not really intuitive in CSS. I'll just show you. This is an example of a CSS animation that I made. I'm sort of proud of. Anyway. But as you can see, there's a limited number of motions that you could do. And even doing this, if you were to envision doing this in JavaScript, it would not be that big of a deal. It would be a little bit involved, but you could get around to it. In CSS, it was a pain in the ass to do. And yeah, that looks pretty cool though. Now, you might be asking, what is the Web Animations API? That wasn't what I was going to assume you were going to ask, but that's the next slide. The Web Animations API, it defines a model for synchronizing animations and bringing together both CSS, SVG, and native browser animations. So all of these right here. We talked about CSS, 3 transitions and animations. Of course, there's also SVG and SMIL animations, which I have no clue about. And there's JavaScript request animation frame, which your favorite libraries for animation, if you do animation in JavaScript, are most likely using. And these, I'll talk about the libraries later. But the Web Animations API is attempting to group all 3 of these into the same API. This is what I mean by nothing new. This is the Web Animations API. You have everything with CSS, SVG, and request animation frame all grouped into one thing. Before, these were 3 completely separate entities, but now you have JavaScript powered API to make it all be the same API. That was a weird sentence. All right. All right, so 3 popular animation libraries: Velocity, Transit, GreenSock Animation Platform, and jQuery. These are the 4 main ones that people use nowadays for animation. jQuery is not really efficient. If you guys are using jQuery for animations, I recommend using any of the other 3. Velocity can be used on top of jQuery, and it also can be used standalone, as can Transit and GSAP. But all 3 of these use request animation frame. If you guys don't know what request animation frame is, you're not alone. I'm sorry too. But request animation frame means that the browser, JavaScript can tap in to each frame, request it, and execute a set amount of code for each frame. This runs on the main thread, and if you guys probably already know, JavaScript is single-threaded. So, JavaScript execution on every frame means that heavy calculations can cause jink. Why? You have 60 frames per second to work with. Do the math, that's around 16 milliseconds. And doing something in 16 milliseconds is pretty hard. I know I've tried. It's also not declarative at all. Caching helps with this, but that your JavaScript on each one of those requested frames. So if anything takes longer than 16 milliseconds to do, then JavaScript says, hey, we ran out of time, the frame already executed, and so we're just going to skip it. We're not going to render it, and that's where you get your lag and your jank. So the Web Animations API is performant. Why? It uses a separate thread, which is the browser, to hardware or accelerate animations. It does it for qualified animations, which means that if your animation does not depend on anything that's happening in the main thread, such as layout or other calculations, then it's going to offset all of that animation over to that separate thread. This is very good because this means that the web animations in JavaScript can be just as performant as CSS hardware accelerated animations. And to do this, the Web Animation API completely refactored its animation engine that both CSS, SVG, and request animation frame uses. And the funny thing is, you guys didn't even notice because it happened 6 months ago, right under your feet. Everything fits so well together that the animation API just works. And it's available in Chrome and I believe Firefox right now. So enough talk about what the Web Animation API is. Let's find out how we could actually use it. So can you guys see this all right? Or should I zoom in? I'm going to zoom in anyway.
Yeah, zoom in a little bit.
All right. So if you want to get up and running, this is like the hello world of using the animation API. First, you get your elements, whatever element you want to use, not using jQuery because you are big boys and girls now. And you use elements.animate to specify two things, the keyframe effect and the timing object. Now, if you've done animations in CSS, this should look familiar to you. All we're doing is we're going through 3 different steps. Our first step is nothing is shown, and it's sort of scaled and rotated. I don't know what my motivation for those numbers were. But in the middle, it shows it's completely opaque, and then it scales back to its normal self. And then at the last frame, it just sort of disappears and twists. It does this in 1 second, and it goes on forever. So pretty simple, right? When you call element.animate, the animation runs automatically. It's already playing. Now, if you want to do pretty much the real meat of the animation API, then you would use a constructor, animation. Now, there's 3 constructors we're going to talk about, and they're all what we call animation nodes, which they return a player, which you could use to play, pause, stop, all that sort of stuff. So let's take our same elements as an example. And we're now going to construct a new animation. And this time we're going to give it 3 things. The first thing we're going to give it is our element. And the next 2 things are the same 2 things that we used before. The only difference is now, as you can see here, you could manually play the animation by tapping into documents.timeline and playing that animation. This means that in JavaScript, you could control exactly when your animation plays, and you're able to synchronize it with other animations. So in review, animation, 3 things: the target, the effects, and the timing. And I'm going to post a slide, so there's a link to the specification right over here. Next one is animation group. This one is interesting. The easiest way to think about it, though it might be a little misleading, is to think about it as a group of animations, like we've just made, all occurring at the same time. In reality, it's just a way to group these animations. Now, the animations are all going to occur at the same time, but they are going to respect the timing of the animation group. So if one of these animations is over a second, over 1,000 milliseconds, it's going to get cut off right at that 1,000 millisecond mark. And this just says that it's going to go on for 4 iterations. And then you do the same thing as before, document.timeline.play your animation. Oops. So the difference is that you're not providing it a target element. That's for the animation. But this also means that your animations can be hierarchical. And this is bringing something back from Flash that we didn't really have before. In Flash, you were able to group and sequence animations if you guys played with Flash before. I used to make those stick figure cartoons. It was pretty fun. And all you give it is an array of child animation nodes, which could be animations or animation group sequences, which we'll talk about. And you could give it a timing object. Here, the timing object is optional, because if you don't give it a timing object, it's just going to take the timing of the longest node. Makes sense. An animation sequence is a little bit different. It looks the same like a group, but each animation is going to occur right after each other. Again, it respects the timing of the animation group in that if one of them goes over a second, it's just going to be cut off or not even shown. So that's the main difference between a sequence and a group. Now, if you want to space them out even further, you could add a delay. You could manually put an offset, but you have to read the specification for that. So like an animation group, except they're played right after another, and it's the exact same parameters as you would give an animation group. To compare a sequence and group, this is from the specification. A group all occurs at the same time. A sequence occurs right after each other. Make sense? All right. Composite animations. This is one of the really cool things you could do with the Web Animation API. Here, you could actually nest groups, sequences, and animation nodes together. You can't nest anything inside an animation node. That's the smallest unit. But you could put groups and sequences inside of each other all day long. And in this, we're putting an animation sequence inside of an animation group, and then animations inside of that. So to visualize a composite animation, let's say you have one main animation sequence, and you have an animation group. The animation group, remember, is treated as a single node. So it's going to happen right after the first node, and then the third node is going to happen sequentially right after that one. You also do player controls, which are really useful. Play, pause, reverse, finish, cancel. This is something that is pretty much impossible to do in CSS. And it gives you a lot of control over your animation. And there's a lot of cool demos that you guys could check out to see these player controls in action. I provided a few links here for you guys. There's a bunch of Web Animations API examples, and there is 2 links here to try it now, one of which being the Web API polyfill. This is new, and it's Chrome is pretty much the leader in implementing this Web Animations API. Firefox is getting there. Safari is just seeing what happens, and Internet Explorer has it under consideration, which it's never going to happen. This polyfill will let you use the exact format that we used before, all of these guys, in any of these modern browsers, if you call IE modern. But it uses request animation frame, which won't be as performant. But the important thing is that you use the API anyway, because once those browsers finally, eventually implement the animation API, it's just a matter of saying, hey, I don't need the polyfill anymore because it already works. And the polyfill does detect if the Web Animations API is already in the browser. So thanks for listening, guys. I'm going to show you a few examples right here. Hope you like the goats. One of my favorite examples is this. This is something that shows what you can't do in CSS, and that's syncing animations with each other dynamically. So there are two cats here, and if I were to add a cat, I'm going to try time. Basically, I'm trying to make them run at the same time. All right, so that was pretty damn close. Let me try another one. All right, here we go. This is CSS right here. You see the cats really aren't synced. However, using the animation API, no matter when I add a cat, let's add a few more, they're all going to play at the same time. No, I'm a goat man. All right, the way this works is, let me get rid of this. One very, very, very simple line of JavaScript. Hold on, let me zoom in here. All right. Where is it? All right. So there's a function here. Let me zoom in correctly. All right, whatever. Animate. Can you guys see that? I don't care. Animate new cat with WA API. Basically, we're just adding a cat, which adds an element, and then we're animating it the same way that all the other cats are animated. And this is a line that does magic. We could set the start time of that cat to the start time of the already running cat with that one line. So the API is very succinct and very useful. There are some really cool demos that I really encourage you guys to check out. This one is really trippy. It's one of my favorites. Here we go. Web API. And with each one of these demos, you could check out the, this one was the main one that sort of demonstrates the true Web API. And of course, each one of these, you could just jump into the source code. And all right, that's not, there we go. You get an actual globe. It's pretty cool. It spins. I don't know if I can interact with it. No. I could pretend to. And there are a few more examples here that show even touch interactions, which of course are impossible with CSS, which makes me really sad because I love CSS. I take Atwoods Law to the extreme. If anything can be done in CSS, I will do it. So, oh, here's an example of playback control too, where this works better on a phone, but basically, when you touch and drag, you could control what part of the animation you're on. So you could also reverse it, which looks exactly the same as playing it. I don't know why they did that. And you could go to the end. But yeah, Web Animations API, really, really cool stuff. And now more people know about it, which is good because it's less than a year old. I encourage you guys to go play around with it and to make stuff move on the web. It's going to make people like your application or whatever you're building more. All right, thank you guys. Any questions?
So, you said that there's a polyfill to make it cross-browser compatible. Are the hardware accelerators features going to be there with the polyfill?
Sorry?
Probably not. The hardware acceleration isn't going to be there with the polyfill.
Not necessarily. That's what things like Velocity and GSAP are good at, because what they do is they could predict animations and then cache them. So you're going to be performant, but you're not exactly going to be as hardware accelerated as you can be with CSS. All of these, the polyfill, its one biggest limitation is that it's manually editing the CSS. In much the same way when you guys played around with jQuery, fade in, fade out, you could literally see like style opacity 1 and then does a whole bunch of decimal numbers and then goes to 0. So it's sort of doing the same thing. And the Web Animations API, the real one, tries to remedy this by offsetting that as if it were CSS. But it's still going to be performance. You're not going to notice a difference in performance. So
the few examples that you've shown were using sort of CSS states as keyframes. Is it possible to use this with something like HTML5 Canvas?
yes, actually. So there are 3 types of effects that you could use, and they're called effects. There's the keyframe effect, which is what we demonstrated. There's the motion path effect, which is using SVG motion paths to move an element along a curved line. And there's what's called the custom effect. The custom effect allows you to add a custom callback where when the Web Animation API can't do something, like it can't go into its CSS or SVG powered functions, it will just call that callback. And that callback, you could do things such as animating from the canvas and doing complex animations like that. So the answer is yes, the Web Animations API could do that. You had a question?
Yeah, so you said there's a polyfill, so what happens when you get an IE? I mean, it still works, or?
I haven't tried it. Sort of don't want to.
So if you were going to write a website that you wanted all the browsers up to say IE8 on that level old, and you want it to still work and not crash, or are you going to have to code around it, like if in this browser do this, but in this do this, or are you going to pick a different framework?
I'm pretty sure IE9 and up can handle it. Personally, I like to play it safe and go the path of progressive enhancement, or progressive IE shaming, as I like to call it. But yeah, it says it works with modern browsers, so I'd say it's at least a guaranteed for IE10 and up, since those are the evergreen IE browsers in a forest fire.
They're building the new, it's called Spartan.
Spartan?
It's going to be able to run a lot of
Yes.
APIs.
IE12.
And it's going to let you download Chrome probably 10x faster.
Yeah. Any other questions?
If you put a bunch of animations on your website, is that not going to slow it down at all, right?
Here's what slows down a website. Or actually, let me tell you what doesn't slow down a website. Opacity and transform. Those might seem like your options are limited, but they're really not, because transform can do a lot of things such as scale, rotate, skew, a lot of things. And opacity, it's just very simple. Anything that tries to what we call modify layout, those are what's going to cause your hugest bottlenecks in your application. So things such as even modifying top, left, width, height, you try to do that, and then, yeah, if you have a lot of those, your animation will choke. But browsers are resilient enough where if you stick to opacity and transform for the most part, they're still going to be pretty performant even if you have hundreds of elements. Anyone else? All right.
All right, so now I'm taking over.
I need more goats, yeah.